This is the second video on volume of solids. The first video looked at prisms. Prism was a shape where if you sliced through the prism anywhere parallel to the end face, you got the same cross section all the way through. So this cylinder has a circle here in yellow. If you slice anywhere parallel to that yellow circle, you'll get a circle all the way through from one end to another. This circle as a cross section moves along the height. That's the length of the prism or its depth. Here's a pentagonal prism. This pentagon continues all the way through the shape, so the pentagon moves up and down the height. Anywhere you slice along the height parallel to the yellow end face, you'll get this pentagon. So it's got the same cross section all the way through, same cross sectional area, an identical shape all the way through. The volume was area times height. The area of this cross section, which is the same as the area of the base, times how deep or long the prism is. All the prisms we deal with have the height at right angles to the base. If you have a pyramid and you were to slice through a pyramid parallel to the base, you'll not have the same shape all the way through. You'll have a scaled down shape. It'll get smaller and smaller as you move up through the pyramid till it comes to a point. So, for example, here's a square base cuboid in red. Inside it is a pyramid, a square base pyramid. If you slice through the pyramid, you get a square, but it's reduced in size all as you go up the pyramid till it comes to a point. So that's a pyramid. Again, the height is at right angles to the base. So it's got an area of base, it's got a height, but we find the volume of the pyramid is always 1/3 that of the prism. So the prism was V equals AH. So the volume of a prism, AH, for a pyramid is 1/3 AH, 1/3 of the volume of the prism. So this is in red a cuboid, a square based prism here, and the pyramid inside it is 1/3 of its volume. Prism here is a circular prism, it's a cylinder. The cone inside it is 1/3 the volume. If you were to take the cone here, it's the same height as the original prism, it's got the same area of base, but it's got 1/3 the volume. So this is the pentagonal prism in red. Inside it's the pentagonal base pyramid. That pyramid has 1/3 the volume of the prism. It's got the same height, it's got the same base, but 1/3 the volume. So, knowing V equals AH for a prism, it's V equals 1/3 AH for a pyramid. So, every prism here has a corresponding pyramid, same base, same height, but 1/3 the volume. So, there's a prism V equals AH, this pyramid is V equals 1/3 AH. So here's what the results are. On the left is the prisms. We've had this from the first video, V equals AH and V equals pi r squared h for a cylinder. So for a cylinder we just replace the area by pi r squared. I mean, it's a common formula here. There's a corresponding pyramid. Same area of base, same height, 1/3 the volume. So it's the same formula but with 1/3 sitting in front. And like the prisms, you make sure the units of the area match up with the height. So if the area of the base is in square centimetres, your height needs to be in centimetres, so the volume's cubic centimetres. Otherwise it's very like prisms. There's an area of base here you've got to calculate. You multiply it by the height, but because it's a pyramid, you divide by 3. So the area of the base is a square 10 by 10. So the area times the height, 100 times 12, but divide by 3. So there's a formula, 100 times 12 divided by 3 this one, V equals pi r squared h for a cylinder, V equals a third pi r squared h for the cone. So again, this is still a third AH, but we just, for a cylinder, usually use this pi r squared h. So for a cone, we use pi r squared h as well. So radius is 6, half that 12, the height is 20. You put these into the calculation. You can either replace pi and round off your answer, or to get an exact value, you don't replace pi, you just work out 6 times 6 times 20 divided by 3. That's the answer if you replace pi. That's 3 significant figures in the rounding. So it's just a third in front of the prism formula. This one is a cone with another cone chopped off the top. And you have to get the volume of this shape in green. So its diameter is 12 at the base. And there's been a big cone there. So there's been a big cone. You should see the dotted line completing the cone. The full height of the cone is 15, the largest cone, and the base is 12. And then there's a cone chopped off the top, smaller one. Well, its height is 5, and you have to get its diameter here. Now, this is covered in similarity. It's similar shapes, so the similar shapes videos. And it's simply a case of the height of this top cone is 5 and the big cone would be 15. So this little cone on the top is 1/3 the size of the big cone. So when that's 12, this must be 1/3 of it, 4. The diameter here is 4. So it's simply similar shapes. Set of videos on that about scaling shapes. The large cone, 15, has been scaled down to be height 5. So it's been scale factor 1/3. So 12, get 1/3 of it is 4. So there's a big cone, 12 by 15. There's a smaller one, its diameter is 4, 1/3 of the 12. 15, 1/3 of it's 5, 12, 1/3 of it's 4. So you simply use V equals 1/3 pi r squared h in each of them. So for the first one, the big one, radius is 6, height is 15. Smaller one, radius 2, half that 4, radius 2, height 5, you slot that in. Take the wee one away from the big one and you get this shape. Notice, only round at the very end. These could be kept as multiples of pi, and at the end you can have an answer as a multiple of pi and then turn it into a decimal if you want a decimal answer. So it's going to be a worksheet which you can get if you click the link in the description. It'll have straightforward questions where you simply use V equals 1/3 AH. Then it'll have questions where it tells you the volume and you work back to find out a missing dimension, like a missing height, or in this last one here, number 10, a missing side of a square. So that's working it backwards. And then it'll have questions where it's composite shapes. So here, for example, a cylinder and a cone's put together, cylinder with a cone missing, 2 cones stuck together, and ones that you just saw, a big cone with a little cone chopped off the top. And it'll have the answers with them. Same link will give you access to the notes which cover all the videos on volumes of solids. So I hope you found this video useful. The next video will bring together all the formula in the first 2 videos plus the sphere and look at composites. I hope you found this video useful. Thank you.